Alright, so this video is going to be part 7 of our convergence divergence problems with series. Okay, so we want to prove that the series is absolutely convergent, conditionally convergent, or divergent, and our series is right up on the board here. The sum from n equals 1 to infinity of negative 1 to the n times 3 to the n minus 1 over n factorial. Okay, now you see this factorial here, go right to ratio test, okay? I said that in the last video. You see that factorial, don't bother at all with trying to do any test for divergence or anything like that. Just go right to ratio test. We take the limit as n approaches infinity of a sub n plus 1 over a sub n. And, well, when we do that, we get the limit as n approaches infinity of, this is going to be, well, a sub n plus 1 will be negative 1 to the n plus 1, and then it'll be times 3 to the n over n plus 1 factorial, and that will be over, well, this will be a negative 1 to the n times 3 to the n minus 1 over n factorial, and of course we have absolute value there. Now this is a mess right now, so let's clean it up a little bit. We're going to get the limit as n approaches infinity. Well, if we do an absolute value here, I mean, to get rid of this negative 1, that's all that stuff is not going to matter at all. Okay, so that goes away with the absolute value, and then you're just left with all positive terms. So really, we could just say here that we have the limit as n approaches infinity of 3 to the n over 3 to the n minus 1 times, we have a n factorial over n plus 1 factorial. When you do this limit out here, you have a 3 to the n over 3 to the n minus 1, and that's just going to give you 3, okay, because you're just going to get when you subtract this, you'll get a 3 to the positive 1, okay, so you get the limit as n approaches infinity of 3, and that 3 is going to be multiplied by what comes out of here, and we've done the n factorial over n plus 1 factorial plenty of times. We know that that's just going to be 1 over n plus 1. Okay, and if you're new to this video and you haven't watched the previous ones, well, this n plus 1 factorial, that gets broken apart into n factorial and just n plus 1, okay, and the n factorials cancel out, and you're left with that n plus 1 in the denominator. So, of course, the limit as n approaches infinity of this is going to equal 0, less than 1, so that means that this is going to be absolutely convergent by the ratio test. Alright, and we have our next series up on the board here, the sum from n equals 1 to infinity of 1 plus n over 4 plus 7n all to the n power. Now, when you see something like, it's everything raised to the n power, then you skip right to root test, okay? So there's definitely cases in which you should skip to ratio test or skip to root test. Okay. When you have a root test, it's pretty much a dead giveaway. Okay. So, yeah. Anyways, we take the limit as n approaches infinity of the nth root of the absolute value of a sub n. Okay. And if we're doing that here, we get the limit as n approaches infinity of the nth root of, this is now, well, the absolute value doesn't really matter here. We're dealing with all positive terms, so we just get 1 plus n over 4 plus 7n, and that's all going to be raised to the n power. Now, the nth root cancels out that nth power, and you're just left with the limit as n approaches infinity of, now this is just going to be a 1 plus n over 4 plus 7n, and of course we know that that's going to be equal to 1/7. Okay, now we're doing a root test here, so we need to be comparing what this is in regards to 1. Well, 1/7 is less than 1, so this is absolutely convergent by the root test. And that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.